ये मेरा स्क्रीन आपको दिख रहा है ना?
दिख रहा है सर।
ऑडियो भी क्लियर है?
हाँ, एकदम क्लियर।
ओके डन। Good afternoon, everyone. Welcome to today's session on Civil 3D Road Design Workflow from alignment to corridor using the subassembly as well subassembly composer. I am Dr. Abrar Khalak, and today we will learn one of the most important workflow used in highway and road design project. Okay, by the end of this session, you will understand how a simple center line alignment is converted into a complete 3D road corridor model using this Civil 3D and subassembly composition. So, this workflow is widely used in highway, expressway, urban road, and infrastructure projects across the industry. Now, before moving ahead, let's quickly revise what we learned in the previous session. First, we create the existing ground surface, okay, in a previous lecture, and then we go for the alignment creation. We generate the alignment which represents the center line of the road. After that, we create the existing ground profile and finally develop the design profile. Today, we will continue from this point and transform our design into complete 3D corridor model. So, what is our today's learning objective? In today's session, we will learn how assembly work, what sub-assemblies are, how to create custom component using subassembly composer, how .pkt files are generated, and finally how all these elements come together to create a corridor model. These concepts are extremely important because corridor modeling is the heart of highway design in Civil 3D. So now this is the complete workflow of road design in Civil 3D. Everything start with the surface, then we create the alignment. After that come profile design. Next we create an assembly. The assembly may contain standard or custom sub-assemblies. These are then used to generate the corridor. And finally, corridor surfaces are created for earthwork and quantity calculations. Always remember this workflow because almost every highway project follow this sequence. Now, you can see the typical road cross section of two-lane highway. Okay, as you all are experienced, this is the you can show the different layer of the road: subgrade layer, sub base layer, WMM, DBM, and BC layer. Here you can see a side slope. This is our natural ground. This is our center line. This is the grade, the lane 1 width, the lane 2 width, the total carriageway width 7 meter. This is the formation width from starting to end. Okay, this one may be side shoulder, shoulder of 2.50 meter. So how this is our cross section look like? So in assembly, so this whole cross section is known as assembly. Okay, so we create this cross section, and the different part you can see here: the first lane, the second lane, shoulder from this right side, shoulder in left side, the slope we given. So everything they are known as the sub assemblies. So sub assemblies when comes together, it becomes an assembly. Now, if I told you about the assembly, an assembly represents the typical cross section of the road as you can see in the figure. Think of it as a template that define how the road should look at every channel. So now in front of you there is one template, and you can see that every channel this road look like this. The assembly contain different components such as lane, shoulders, drain. Maybe drain they provide here or here as per the cross section element. then side slopes. So whenever Civil 3D create a corridor, it repeatedly applies this assembly along the alignment. Okay. Now to understand this assembly, see assembly you understood. Now to understand the assembly better, think about a real road. A road is not made of only lanes; it includes the different part that we discussed. When all these individual elements are combined together, they form a complete road cross section. In a civil 3D, all these components together from an assembly. Now you can see here, you see this part, you see this part. Okay, this is a cross section. Now this cross section, how it look like into this civil 3D. So this type we can create into the civil 3D. This is our center line, crown area. The right side lane one, the left side lane, the lane width, slope of the lane, then the shoulder, slope of the shoulder, both side, the full carriageway. Then this one is our left side, this one is our right side. Then we provide the daylight for the quantity and cut and fill criteria to maintain them. Again, we have the side slope for the gutter. So this is the assembly look like into the civil 3D. I will just give the example of it. And this is the tool palette. So from here we can take assemblies from here, and we provide this sub assembly, implement this sub assembly into this crown section area. Now this tool space, you know already that you can manage your sub assembly from here also. And this is all the properties that what we used here. You can see the name, type, site, station, end station, then the width, slopes, and the description key set. So these all things are comes within this civil 3D assembly parts. Now, what is sub assembly? So in a simple, a sub assembly is an individual component of an assembly, as I already told you. For example, one lane is a sub assembly, one shoulder is a sub assembly, one curb is a sub assembly. When multiple sub assemblies are combined, they create the final assembly. So, in a common sub assembly used in a road projects is like lane, shoulders, median, curb, drain, daylight. So, each sub assembly perform a specific engineering function. By combining them appropriately, we can model different road types. So, tool palette contain the standard sub assemblies provided by the Civil 3D. We can simply drag and drop this component into the assembly. For the most standard road projects, this built-in sub-assembly are sufficient. However, when special requirement arise, we need custom sub-assemblies. So I will show you this tool palette also. So first I go through the theory so that when you heard the same name into the software, so you will not get confusion. Now, creating our basic sub assemblies. So here we start creating a basic assembly into the software. First, we create the assembly baseline. Number one, we create the baseline first. Remember this. Sorry. First, we create the assembly baseline. Then we add the lanes. Next, we add the shoulders. Finally, we add the daylight and slope as per the requirement. And this create a simple road section which can be used for the corridor generation. Now we can see the completed assembly just after this into the Civil 3D software. In that, you have to notice how each component has a specific width and slope. The lane define the carriageway. The shoulder provide the edge of support. So you see the name like edge of support, carriageway in a short form. The daylight connects the road to the natural ground. So keep it here. Let's go into the software. Now this is our interface. Now let's start this thing. Let's import the point first. For importing the point, we have a lots of option here. You can import by choosing anyone. Okay, let's go into your batch number, our folder. Okay, now we have one point set here, and it is in PENZD format. Okay, okay. Now our point is here into the file. Now we have to enter ZE extend. So your all points, you can show this all points set here. Okay. Now what we do, first we create the surface. I am not taking too much time here. We give the name as a EG surface. Okay. Now let's add this all point into this surface. So I add this all point group into this surface. So now our surface is created. Now what I do, I have to remove this point so that I can work properly. I will show you all the thing properly. So for that I select one point and then go into the point group, and from here I select our point style as none. So all point are gone. Okay, done. Now this is our surface. So for creating the assembly, what we need, we have to create the alignment. So let's create the alignment first with the help of this alignment creation tool. Let's give the name road number one. Okay, and I'm not setting anything here. Okay, okay. Now let's create one road here. So this is for the education purpose only. So that's why I'm just creating a road here, road type of structure. Okay. So this is our road one. Now I will show you the next. Again, what we do, we create a road 2 again. So here we give the name road 2. Okay. So I have to click the shift right click for select the nearest point on this alignment. So let's say that our road 2 is come from this area to this area. Okay, now we have two roads here. I'm not doing so much thing into this alignment part. We are just proceed till what we learn for this. Let's click on the alignment number 1, road number 1, and create a profile. So first I have to add this surface and then I have to draw a profile here. Okay, let's click here. So I have the road 1 profile right now. Then again I click into the road 2, and then again I go into the surface profile and add this surface and then create a road 2 profile. Okay, I click it here. Now we have a two profile for road 1 and road 2. Now let's select this profile view and go into the profile creation tool. Then we can give the name as design profile for road 2. Design profile road 1. Sorry, road 1. Okay, to understand that what we are going to do here. Okay, now I have to draw the design profile to by setting all the criteria perfectly. So So this is our road 1 profile. You can see the grade here. Okay, now for the road 2, what I do, I select the road 2, select the road 2 profile. Then again I go for the create profile. Here I can give the name as design profile road number 2, and then again we create the design profile for the road number 2. Here also we can create a profile. Okay, now this is our road 2 profile. So you can manage this profile. You can manage this profile like this. Okay. Now, Rajiv ji, your concern is this grade not showing. So this type we select with the label. So that's why all the label is showing here. Now you can manage all the thing with the help of this. I hope you understand that whatever the difficulty you face in the previous lecture, that how to check the grade here.
Hmm.
Okay, now we have surface, we have alignment, we have a two profile for profile 1, profile 2. For both we have a design profile. Now understand why we do this work. So the first purpose is for revising all the things in a smallest time period. And the second thing, to create the assembly, we need alignment, profile view, and design profile view. Okay, now let's come for the assembly part.
Sir,
Yes,
sir, once you repeat the band set, how to set band in profile?
okay, I will show you that also. Select your profile. Okay, then go here into the profile properties. In profile properties, you can see into the profile. What you have here, we have the elevation only. So first we delete this one. Into the profile we can add elevation and station or whatever our requirement. Like you can see lots of things here. You can add the profile data, standard data, widening data, then median edge, drainage edge, road center line, ROW, the datum. So all this all are template only. Okay. Again, as previously we imported your band set, we have that band set also. So if you want to see the curtain fill criteria, you can set the curtain fill criteria and set is okay. Now your curtain fill criteria is here. Now for the profile one, we check the surface profile, and for DP profile, the same here you can set. Now you have to
Now, sir, for next band, if you
yeah.
want to add in
Now
same.
see, this is your fill and cut criteria is here.
Hmm.
What is your question, Rajiv ji?
My question is, you create the cut fill band.
Hmm.
Then I want to horizontal alignment and vertical. Uh, then how
Horizontal data, vertical.
then
Okay,
how
see,
we
now into from the band type, from the
yes,
band type,
how
you
to
can
add.
go here the vertical geometry.
Okay.
Okay, as you go into the geometry, here is a style. So we
Hmm.
have to select any style. Like for geometry, I use the geometry style, and then I add that style here.
Okay. Click the add and next another band is set.
Okay, now you see, because this is the general style. Okay,
Yeah.
so we directly set that style here. If your style is not shown here, you
Hmm.
have to save this style as a band set, and
Hmm.
then import that set.
Hmm.
See, apply and okay. Now you see your horizontal thing is here, but this is in a inappropriate form. So for that, what you have to do? You have to go in the profile properties view, and from here you have to manage that what surface you have to select. Okay, I hope you understand these things.
For multiple bands, sir, go to the command, sir, once again.
See, I will show you that here we have to go into profile view.
Yeah.
Okay,
Yeah, you
now
see the geometry ones. If I want to add another profile like horizontal geometry, then go to add bottom.
see, let's delete this one. I will show you again this. See, now I don't have any band. If I click apply, then you can see the band set is gone from here.
Mm,
Okay,
okay.
from the road 2. If I delete this band set and apply, then you can see we don't have any band set here.
Mm,
Okay, now your question is how to add the band set into the profile.
yeah,
Different type of band set.
yeah, multiple benches.
Yes, multiple band set. Now, Rajivji, what happened here? Every company has their own templates. So you have to, work under that template only. So if you have that template, then well and good. You
Mm,
just import that band set. Okay, you just import that band set from here, and you can see all the band detail is there. Now, like I will show you that I have this band of cross road.
mm,
Okay, as I imported this, see what I have. I have the profile data, horizontal, vertical, all the different changes, FRL level, EG level. Understand what I want to tell you. So every band set has their own different level, whatever they want to show to the client. So all the company have their own specific criteria. Now, if I want to create my own, if I want to show my own criteria, then what we do? First of all, now we don't have anything. Okay, we again I cancel. We don't have anything. Now I select the profile. Then I go into the profile view properties. Then here into this profile view property, what I have to do? First of all, I go into the band. First of all, I have to provide the name, rename it first because this is your new band. So if I give the batch name as a batch number 76, now station elevation. So this I don't want to change anything. Now into the band. In a profile, what I want, first of all, I want the elevation and station. Then I add this elevation and station. Now all the elevation and station is here. The second thing, if you in a profile data, you want like a change for the utility. You want the datum design, e.g. crossroad. Okay, you have to add this. Okay, now you want the cut data only. So you have to add this cut data here. Now if you want field data, you have to add this field data here. Okay,
okay.
now you have a 1, 2, 3, and 4 band.
Mm,
But first, what we do, we save this band set. Whatever we create, we have to save this. Okay.
mm,
So we how we set this band set? We have to give the number page number 76.1. Now apply and okay. Now we have this one band set. If I apply and okay, now this band set is you can show here the four thing 1, 2, 3, and 4.
mm,
Okay. Now
mm,
here you cannot see anything. So if I want to provide something here, I have to select this profile number one, go into the property. Right now I don't have anything here. But what I have to do, I have to import the new band set. What band set you want to import? So we made a band set base 76.1.
mm,
The same thing come here. Now you have to apply and okay. See,
good,
the
good.
same band set is here.
Mm.
Understand?
Yeah, understand, sir.
Okay, okay. So again
Fantastic.
I go for the profile view property.
And
Yes. Okay. Shall I move on?
oh,
Rajiv ji,
Yeah, sir.
shall I move on?
Okay, sir. Okay.
Yeah.
I
Okay.
understood, sir.
Okay. So what I do, I just want this station and elevation here the same way. So right now we are not going deeper into this part. We are focusing into the assembly. So that's why I will keep as it is. Okay. Now I have to provide the assembly. For what? What we have to do? We have to go here into the create design panel. Here you can see the assembly. See, create assembly. You can create your assembly with the help of polyline also. So if you extract this create design, you can see here create assembly from the polyline. Okay.
Okay.
Okay. Let's go with the create assembly part. So as you click on the into the create assembly, you can see the first name I have to give. So first name, let's we give the assembly number 1. Okay. Now into the type. So lots of type is here. You can select any particular type, whatever you want. Then this is the assembly style. So you can provide any basic style you want. If you want basic, standard, default, so whatever style you like, you can. So this is the shading part, hatching part. So let's go with the hatching part. So whatever the section you see in H per in a hatching is there. Okay. So let's click OK. As you click OK, you can see here specify assembly baseline location. Okay. You want to if you want to focus if you want to focus. See, if you want to focus this part, what we do first, let's go for the, let's set the viewport. Okay. Um, so we have to set our view cube as per how we look good. Okay, now it's good. See, what we do, we are working here for the alignment part. Okay. Now this is our 3D view. Okay, let's make it 3D. So this will be our 3D view. So whatever the work we are performing here, you can see here into the 3D view. And this part, so this is the part where you have to focus. Okay. Now let's create the assembly. As you select the assembly, we have to give the name as assembly number 1. Okay. Now all the thing is okay. Now okay. Now it will ask us specify the assembly baseline location. So let's click here. So as you click on to the location, it will automatically zoom out and focus onto the that assembly baseline. Okay. So now we work here into the assembly baseline. So now we have the baseline here. Now what we have to do, you can see we have this tool space here. Into the tool space, this four you can see here in a prospector setting survey and toolbox. Now this one tool palette, you can open it by pressing the control 3. Okay. Now we have this tool palette here. As you click off the tool palette, this tool palette go from here. If you click on this, the two you can see the tool palette here. Okay. Maybe in your computer you can see your tool palette here or here anywhere. You can adjust this from this side to this side or this side as per your suitable location. Now as our tool palettes open, what we have to do, we do right click here and you can see the different option here. So first we have to set that I want to work into the metric part. So you have to click civil metric sub-assemblies. As you click, now your all sub-assemblies are working in a metric view. Okay. Now you can see here we have a different type of sub-assembly. So this is the uh, ready-made sub-assemblies, basic assembly, basic lane transaction, divided highway. So this type, the different sub-assemblies there, assemblies is there. It is ready-made as per the IRC. But every time the ready-made assembly is not useful for us because for every project we have some different classifications. So we have to create our own. Then we have this basic tool. Here all the basic sub-assemblies given, basic lane, basic transaction lane, generic structure. So all that basic things is here. Then for the lane, different type of lane is here. Here into the solder, different type of solder is here. Here into the median, you can see the type of median. You can create your own sub assemblies too. For the daylight, we have a different daylight. In a generic, you can see the different general parts. Again, if generic is not a last, if you right click, sorry, here, if you right click, you can see this one till the generic you can see here. After that, this one also are there is like if I want to see rail, if I click into the rail, so you can see the rail part is here. Okay. If you go into the bridge, you can see the bridge part is here. If you go into the retaining wall, you can see the different retaining wall here. Now let's see, again we go into our basic part. Now we are focused. Let's what I do, I take our sub assembly part and put it here. Okay, I will show you this first, then we come here. See, see now. First of all, I am going to add a basic lane. Okay, if I want to add this lane, what I have to do, I just click here into the basic lane, select it from here. As you come here, you can see the square box. Okay, point mark. Into this baseline, we have to provide the this part. Okay, now see here, you can see our road is starting from here. Okay, so this is our left side and this one is our right side. Okay, the side is very important. So you have to remember that this one is our left side and this one is our right side because our road start from this part. And this one is starting from this, so our right side is there, left side is this side. Okay, now let's come here. So here you can see this crown part. So we have to select, if I want to put that road, I have to put it here. Before that, as we click here into the basic lane, we have these properties for that basic lane. Now ignore this above part, come here into the advanced part. You can see the side is right, width the width of road is this. So this one here you can see all the things into the foot. So first of all, let's set this in a metric. Why it is coming into the, okay, so this selecting the template is very important. Basic lane. Okay, now don't worry about this. Now it is okay. Now if I want to give the width of like 3 meter or 3.5, so we can set it from here. If you want depth, if you want the depth here, you can set the depth from here also. I think we have to set our unit first.
Yeah, yeah, still in feet, sir.
Yes, meter. Okay. All unit are coming into the meter, nothing is there. Unit is not an issue. What I don't know what is the issue. Let's just give me a minute. Uh, Let me start the new file. Don't worry, I will show you this thing. Okay, let's create the assembly. Now let's go for the basic lane. Okay, now it is okay. Well said. I don't know what problem coming here. Uh, let's again import our assembly. It will happen. It is not a big issue. Okay, let's keep it as a metric. Now we take the basic length. I don't know what happened here in our file. All the criteria comes in feet only. But that's not big issue. Let's come here into the next file. See, maybe I opened the imperial format, so that's why this problem happened. That's why again and again I told you from the first slide that whenever you open your Civil 3D, make sure that in which file format you have to open. Actually, the problem is not the file because the file format is also in a metric. But what happened? Many time when we import some, like from the mainest tab, you can import the band set style from here. So sometime if you import that style into the metric and fit, so that's why this problem will arise. So if we go here, so
Sort file unit should be in metric when
yeah,
you open the metric form.
yeah, it's must be you have to must select it in the metric. I don't know what happened. Okay, let's put it one here. Let's see if we can do any correction from here. Mm,
All parameter in feet, sir.
yes, sir. Okay, okay, let's leave it. Don't waste so much time here. Uh, I can show you this another thing. Okay, let's open another file. Okay, see. Now we have surface. What I do? Uh, I create one palette here also, so you understand. Now see, again what we do? We go here into the alignment tab. We create the road number one in a fast way because sometime it will happen. See, if we have one alignment here like this, okay, now I need profile for that alignment, road number one. So we go here into the surface profile. We have the corridor is a corridor 100 feet ahead. Go into the profile view. Okay, we give it here. So what we do, we save this file into your folder 76. Okay, now remove this part and remove this assembly too. Now we have point and surface. So again we go with the help of this. So now we have the road one. Let's go. See, we have road one now, and we have the NSL surface. Okay, so let's create the surface profile first. We go add, we have to add the NSL, throw into the profile view. Okay, let's create the profile view. We click the profile view here. Now you can see the profile of NSL surface. Now we have to create the design profile. So we can give the name here DP4 road number 1. Okay. So we can manage our this design profile. So now all the grade is shown here. Uh, Now we have the design profile and this profile. Now we have this road one. Okay, now let's go for the assembly. Sorry for this disturbance. Now let's give the number of assembly number one, and let's go with all basic code and all goes. So this is not mattering anything. Okay, let's click the alignment here. Now you see we have this baseline here. Now what happened? When you select this baseline, we have to add all the that palette bar here. So we have to open this palette here. So into the palette we have this basic lane. Okay. Now again it will come into the foot. What happened? Okay, then what we do? I think in my label style there is some problem. So don't worry. If it is in input, I will show you in a foot. It is not in meter, but if it is it will be in a metric, then it will be easier to understand for you. So forget that all the things. Let's start from here. See, is we have this basic lane. Okay, so the first what we did. I delete this. I again go here. Okay, let's start with this assembly part. We can create this assembly. Okay, and then we give the name as a assembly number 1. Okay, now assembly number 11. Now you can see you have to select the assembly type as other. Okay, whatever the type you want, you can select it from here. But if you select the type other, then you can optimize all the rest of the part. Now assembly style, you have to put it as a basic. Now code set, if you don't want any code set, you can select if you want a basic code set, you can select basic.
Sir,
So if
actually,
you,
what is the code set, sir? This is Indian standard code or anything, sir?
no, this code set is in the term of like see, I will show you the code set. Like if we create that, see, I will show you that here. See, uh, if we are right now we are draw any assembly, it will look like this. Okay, so this first layer, concentrate on this first layer. So what code set do? You you here we have this first layer. So this first layer have like it have this material, black material here. It have some other brown material, some white type of material, gray material. So in code set, they the code set is used for to provide the inside material.
Okay, the
It may
different
be in the form of
layer.
hashing. It may be in the form of colors. It may be if you are in a form of shading. If you are saying no, then it will only the line like this.
Okay, okay. Means
Okay.
code means the different layers of in the
Uh, because
road.
we are going after this, we are going into the that part like into the sub assembly composer. I will show you how exactly the code set and all that things work. Because in sub assembly composer, we have to create all these things by our own.
And one question also, sir, in assembly style, we must go in one in the option is given in the civil city like basic and other.
This is assembly style. In the
Yeah,
point in surface, we have a different style.
yeah,
If you select the contour style, you can see this type of line. If you set the water set, then you can see the different color. So
yeah.
this is just style.
Okay, okay. So basic is required for road.
Uh, Actually, I told you that every company has their own standard, own template. So they provide because what happened? Whatever the plan and section and you see from the different client, so they all have some different patterns.
Each company have in profile section or assembly section also, sir. Assembly
Every
section
part,
also.
every part. I will show you. I will after this. I am also showing you in today's lecture that how to import that all styles and all these codes here. If you want to, if you like anyone template, and if you want to import it that template, if you want to use that style into your civil 3D file, then how you can set that? I will show you after this.
Okay,
Sir,
okay.
in
Okay.
basic we customize or not, sir?
Everything is whenever you see this icon, you can customize everything.
Indian style.
Okay, if I set as a basic, like see, if I see India basic, okay, and you can go here, you can copy the current selection and then you can customize it. So for customize the assembly, we need three things: link, points, and shape. So what is this shape? What is this point? And what is this link? You can understand this thing into the sub-assembly composer. So when you come again here, you
Hmm.
understand how this assembly or sub-assembly is created.
Oh,
Okay.
oh.
So I am going this in a step by step. So that's why you understand all the things. If I taking anything in between, then you confused in all the things. Okay. Let's go with this. I am clicking OK. Now I have to click here. So right now we have this style. See, if I change the style of this assembly, you can see in previous one here we have this style. Okay, and right now here if I change the style, you can see the round mark is here. Understand? Again, let's see. I am taking the different style. Alignment number one. I am taking the different style like taking basic. Okay. Again, I click here. Sorry, basic style. This one, assembly style. Okay, okay. And I click here. So now you have the different style. Okay, so this is the this style is look like wearing a cloth. So every time you can give them a different style. So different. In a winter, you are wearing the jacket. In a summer, you are not wearing any jacket. You have only small t-shirt. In a monsoon, you have to keep a raincoat. So as per this, as you are, being fluent, then you need some different style. So you like some style, you can use it. So every time, whenever you give your style to the client, so this will be your identity. That if Rajiv ji give me some file, so this will be in this style. So it will the style is also being your identity as your company identity. So
Okay.
that's why I told you that every company give us a different style. Okay, now let's concentrate here. Let's go into the basic, and you can see the basic lane here. Okay, let's select the basic lane. Now you can see the different width and the depth, all that thing. The
Yes.
slope is minus
Okay.
2%.
Uh, okay, sir.
Okay, so don't worry about this feet and meter. We will take it in a feet, so our time is not going to waste. Okay,
Yes. Go ahead. How to create the assembly? First we see it.
now as you have this part, as you have this part, so I want to apply this basic lane. So I have to click here, see the side, right side, we have a right side here. So I have to put this on a right side only. So as I click here, you can see your first lane is drawn. Okay, now you can manage the height width, like if I want the 10 feet. Okay, as I provide the 10 feet. The depth is I provide 0.5. Okay. So now if you select this assembly, if you select this assembly, we have these two things: sub assembly properties and assembly properties. Assembly properties shown whole assembly property. Sub assembly property shown only this lane property. Okay.
Mhm.
As we click into the sub assembly property, you can see the name, the parameter, okay, the width, the depth, the slope, and the quotes. Okay, so from this also you can change this. Now again we go here into the template and we take a basic curb and gutter. Okay, now after this lane, if I want to add the basic curb and gutter, so this round shape, okay, here you have to click. So our basic curb and gutter is there. So this white part, you can see the white part. So this is that code, hatching and all that things. Okay. So in your computer, maybe it will be in a different style. So now what I do right now, I do it for the right side. As I select this part, you can see the properties here. Into the property, you can see the right side, the name, whatever the standard is there, all that thing you can see here. Okay. Now, if I want to draw this same thing here into the left side, so what I have to do? I have to select this both thing, and then there is a command here: mirror, move, and copy. So as you click into the mirror command and you click here, see the same thing is now into the left side. So this is not a mirror or copy command as you are using in the 2D drawing. So this is specially made for the assembly purpose. So this command is only used for the assembly. So how you can copy this? Again, I delete this. We have to select this. Okay.
Go to me.
As you select,
Mhm.
here you can see the mirror command, move command, and copy command. The first we have to use the mirror. As you select the mirror command, you can see here, select the marker point within assembly for the mirrored subassembly. So we have to select the marker point. So for if I want to provide the subassembly here, what I did, I click here in this part. If I want to provide this part here, so I have to click here into the left side. So as you click, your this board side is there. Now see, sometime what happen. So this is the basic thing. So first, what I do, uh, I provide this assembly into this alignment, the first part. Then I will show you the different thing. See, I have, for that I have to create the corridor, and I have to create the corridor. So this is our corridor number one. Corridor style is there, layer is there. See, for creating the corridor, we need a alignment and profile. So if you don't have the profile, then corridor is not created. So that's why we create the profile. Okay, and we also need the design profile. So we have this design profile DP road 1. Okay, now assembly, we have the assembly number 1, and here the baseline and region parameter I will show you. So right now I will uncheck this and click OK. So as you click OK, you can see your this assembly is provided onto your this alignment. Okay, this line, this line, this line, this line. So this line is nothing but your assembly, this one. Okay, and now you can see the distance between this whole assembly is uneven. You can set the distance by frequency. This frequency, you can set this frequency. So after selecting your corridor, what you have to do, you have to go here into the edit frequency. As you select your edit frequency, you have to select the region. So right now we have only one region. So as I click into the region, so we have that target 82 foot. So what we do, we give 50 feet for each part. So as we have all the things in feet, so we are going around right now into the feet part. So we select OK. Now you can see at every 15 feet we have assembly. Okay. Now see, whatever the thing here you can see here. Right now our assembly is in the air. It is not attached with our surface. Okay. So as we select our this corridor, and you can see into the object viewer, you can see this corridor is created. Okay, and this is the assembly provided here throughout the alignment. I hope you understand this part. Now what I do here, sometime what happen, if you have a road here, and sometime what happen, if there is one another lane, you have to like see from here, if we have one another lane and it is connected directly, see, it is connected directly here at this part, or maybe at this channel. So as you click shift and right click, you can set as a endpoint. So as this part. So what happens sometime, we have some if we have one circular part and some another uh, wide area is coming from here and join through the alignment. So at that time we have to create the different assembly, and we have to give the different length, because this length is you can show the this length here. So this is your alignment. Okay, this one is your lane 1 and this one is your lane 2. The lane 1 is from the left side, lane 1 right side. Now this is your curve. Okay, as you put your cursor here, you can see the back
Corridor
curve
one.
point codes. Okay, as you put your here, you can see ETW. Your end of the pavement is here, lane 1. Same side here, you can see ETW, and you can see the back curve. So every time here you can see the gutter and curb, and then this end line, and here this center part. Okay, the crown part. So this type your corridor is created. Now if we have to if we have this another road, we have this widening, and the widening because on actual road we have the different the area is different, not same at every part. sometime it will coming here from here. So what we have to do, we don't have to use or create the another assembly, but for that, is here in into the assembly, what we do, we create a basic lane. Now we have another lane like basic transition lane. See, basic lane transition. So we can select this basic lane transition. Now we have all that parameters. Okay, you can see the replace option is here. So you can replace this lane by this transition lane. You can select onto the replace part. Now you can select this lane, and then you have to select this round. The same way here you have to select this lane, and you have to share this l- round here, and then click enter. Now your now you see if I click here, you can see the name is as basic lane transition. Now your basic lane is replaced with basic lane transition. Now let's select the assembly. Okay, we go into the assembly property. You can see our assembly number one. Here you can see one baseline. So as I select the this baseline, so we have this one baseline, and in that baseline we have this whole region. As you select the corridor, whole region is selected. Now for this baseline, we have this left side and right side. So the name is very important. So we have to rename this into the right side. We give the right lane. Okay, and here we give the name as right curb and gutter. Okay, the same way I give the name here, but this time this is left. So giving the name is very important, because what happen every time, whenever you give, if you have a proper name, then you can easily identify what on what part you are working. When you have more than 2 3 lane and more than 2 3 assemblies, then at that time it is very difficult to understand that we are working on which assembly or which part. So as we imported the transition lane, so into this lane you can see here the transition. So you have to set the transition like I have to hold the grade and I have to only change the offset. Okay. The same way here in a left lane, we have to set this part. What I'm doing this, I will show you. Hold grade and change offset. Okay. Apply. Okay. Now, what I do, I set as my grade is same. If my assembly is, joining here, I want to set that my assembly is join here on this offset. But I need that my grade, the grade that I provided here for this will be maintained throughout this line. Only the length is going to be changed. So now what we do, we select the corridor, we select this region, we select the corridor, and we give the target. So if we click here, edit target, okay, we select this part. Now you see here offset and elevation. Here we have the left lane, we have the right lane. Okay, so as you select onto the lane, you can see here offset target. If you have the alignment or pipe, you can select it from here. If you have the polyline or line feature line or survey figure, you can target it from here. So for a left lane, I can select this, uh, and I have to keep the target this object. Till now this object is selected, and now I give apply. Okay, you can see the difference. This is our lane, this is our center line, and this is our another lane that we give the offset. So as this lane is connected with this. Okay, I hope you understand this part. Now, now what we do, as you come here into the assembly part, okay, as you select this assembly, if you want to change anything throughout the assembly, you can change it from here. Okay, you can give the name and all that type from here. If you click into the lane, you can set all the criteria from here also. Okay, in information in a codes. This is the first thing. The second thing, if you select any part, like if I want to change this, you have to select this, and then you can give sub assembly. You can go into the sub assembly property, and for that particular part, you can change the thing from here also. Okay, this is the second thing. Now here into the setting also, you can see your assembly. Okay, here all the data assembly style is here. Okay, so you can also change that style and all that things. If you want to show something or you want to remove something, you can do it from here. If you want to change anything, like you want to see that I want a round thing, or I right now we have the crown like this type round, one cross and box, so it will select it as a cross, box and round. You can see here this part. If you want to change anything, like in a previous I select the another style, there is only round, so this type you can change the style from here also. Okay.
So,
Yes.
sir, if I want to add the sub assembly in this assembly, like
Yes.
base, sub base, shoulder, median, how to edit this assembly,
Okay.
or how to add
Okay.
it
Okay.
to.
See now, here in the prospector tab, you can see your assembly here also. So this is the assembly number one that we created. So in assembly, one baseline is here. If I select this one baseline is here. So in this baseline, we have the right lane and right curve. See, we change the name there. Right lane, right curve. Into the left, we have the left lane, left curve. Okay, so you can edit this thing from here also. If I want to change anything from this right lane, you can change it from here also. Okay, now let's see. Now I have to provide a basic side slope. Okay, so what I do, I select this side slope. Now the property is there. Okay, for our cut slope is there, fill slope is there. You can set the your slope as per your requirement. Into the advanced option, you can see everything. Now you can see the side. So I select the side is right. Now I can put this onto the right side. Select this. Now your cut and fill is there. Okay. Same way, if I select this and I want to copy this. Okay, and I want to copy this here. If I copy this, then the same thing is copied. I mean the right side is copied. So that's why what we do, we mirror it. So that's why the side is also being changed when we mirror this thing. So we have to select this. Now into this, if I want to edit this, I have to go into the sub assembly property. I go into the sub-assembly property. In parameter, you can see the left side is there. It means my day and light is into the left side. So this left side is okay. Now if I want to see this one, the right one, I see from the sub-assembly property, the right side is there. Now if you want to change anything, like Rajiv ji, you want to set the slope like 3. Okay, you can set from the sub-assembly property. You can set it from here, like we have 2.001. So you can if you want to keep 3, then the slope is changed from here. Okay, so whatever the property change you want to do, you can change the property change from here into the properties part. Okay, If you want to add anything from here, you can add it from here. If you want the another lane, you can provide the lane here. First, understand the concept, how it this will work here. I hope you understand this part. Now,
Sorry, cut slope. If there is any norms for ordinary soil, soft soil, hard rock, cutting slope and filling slope value is given or not?
see, if we have this cut slope,
Yes.
okay,
Yes.
what we do, we select this slope, we go here sub-assembly properties. From here also you can go. See, we provide this slope, then you can see the slope is also showing here into the prospector tab.
Mm.
We can go it from here also. Now you can provide the name from the here. Yes, this is the right side. So you can type right side slope. Okay, then apply. Now into the parameter you can see company will provide you that we have the cut slope as a 50% and fill slope as a 100%, for example. So you have to set the cut slope here and fill slope here, Rajiv ji.
Yes, sir.
Yeah.
I think Ram Kailas ask you.
Okay, Ram
Mm.
Kailash ji.
Yes, sir.
Ram Kailas ask you the types of soil is
Well,
different, like hard soil, hard rock, or medium rock, or soft soil,
mm.
or ordinary soil. The
Hmm.
different types of soil, the side slope required accordingly. Like 1 is to
Yes,
4.
because Ram Kailash ji, understand one thing. We are just providing the first layer.
Yeah.
Understand?
Yes, sir.
Okay, this is the top layer, so, and this is the slope for the top layer. Now you have the second layer. See this first part. We provide this first part. Okay.
Okay, sir.
Okay. You can maintain this thickness and all that thing. See, if you select this part and if you select this part and you go into the sub assembly property, the depth and the slope and all the things you can manage it from here. Now see, this is the basic lane. Okay, now see, we have the lane. I will show you here into the another part. See, I delete this one. I go here into the I take this part. Now you can see
Mm.
we have the different layer here. Okay, understand Ram Kailash ji?
Yes, sir.
As you select this and go into the sub-assembly properties, here you can see the payment depth one. You can set the depth one payment,
Yeah.
this part. You can set the
Yes.
depth to base depth, sub base depth. The same way you can set the slope also.
Yes.
Okay, because what happened? If you have the this one lane and the second lane is also here at the right side, then you can provide and the lane and the grade is different for both payment, both
Yes.
lane. Like
Yes.
the this grade is 2%, this grade is 1.5%. Then you can set the slope as a 2% here
Yeah.
by giving the by
So
changing the
this
properties.
slope is only camber slope, not earthwork quantity, earth cutting slope or filling slope.
No, this is not for the cutting and filling.
Yeah. Yeah.
We are only talking about the
Camber slope.
yes, because we are still into the assembly part.
Yeah.
Okay,
Okay.
for cutting and filling, we provide here the cut and fill part.
In this, yeah.
Okay, so if we provide this, this cut and fill ditch.
Mm.
Now what happen? How this cut and fill quantity they calculate? Understand? So this is the top part. From this point, to the this point, the top of the surface, then
Mm,
it go this point, then this, and
mm.
from this point to, if there is a cutting, then it will go. There is a filling, a cutting, then it will. Uh, this line goes to the this part and attach to the ground. If there is a filling, then it will go to the this part and attach to the ground, because our corridor is not attached with the surface. See, this surface is different, and our corridor is not on the. You can see here into the 3D part. Our corridor is not onto the surface. It is in the ground. The surface and the corridor is not attached. Understand? So for that we have to create the corridor surface. So once we create the corridor surface, so how they calculate the surface? They calculate the surface from this top link to the ground surface. So from that part you can calculate your cut and fill criteria. So I'm going on this also. Don't worry about it. Now I hope you understand these things. Whatever we go through right now. Now just give me 1 minute. As we are not taking a Saturday session, so kindly be patient. Today I am taking some half an hour more. I
Okay,
hope
sir. No
you don't
problem.
have any problem. Okay. So right now, what we are going to do? Just give me 1 minute. Water break. 10 second of water break. Then we go further into it. So this is not a hard part. Very easy part. Once you practice this, it will be very easy. Now we are after seeing this, we are going into the sub assembly composure. Okay. Once the sub assembly composure is finished, then we go for the corridor surface and all that things. Or if we are here and if we want to see the corridor surface, we can go through the corridor surface. It is not a big issue. Now, see, now I am taking this part into the single window so you can see it properly. Now, if I select this corridor, you can come here into the corridor property. You can see the corridor property is here. As I open the corridor property, see, I will keep your corridor here, and I select this corridor and come here into the corridor property. Now you can see here there is a one baseline and one region. Okay, two things is here. If I select the baseline, you can see this baseline in a red part. You can see the baseline. If I select the this region part, you can see the region is here. Okay, so you have to understand these two things: baseline and region. You can add the multiple baseline. In that baseline there will be multiple region. Okay, now see, if I have this full corridor, I want to split this corridor from here. So what I have to do, I select this corridor. Okay, and I go here into the split region. As I select, it will ask select a region to split. As I have only one region, as you see, our this come into one region, one baseline, one region. So I can select anywhere into the region. I can select here. Now it will ask me specify the location to split the region. Okay, so I want to split from here, from this point. Okay, from this point. Now you can see. as I select the corridor, you can see this diamond. Okay. Now, what is the purpose of this diamond? You can manage your corridor with the help of this. See, you can manage your corridor with the help of this. Okay. Uh, this is the marker area. You can set the marker here also. See, now this is your alignment and this is your corridor. Okay. You can manage your corridor and alignment with the help of this cross diamond. Now you can see the another this part you can manage it from here. Okay. Now here you can see and the second region we have two different region. I hope you understand this one. See, we have these two region. We can manage this region from here also. If I want this region from here. So I can reduce it or I can manage this corridor region from here. As you see, we provide the region from here, but with the help of this diamond crossing, what we did, we take the region from there to there. So you can manage this region part from anywhere. You can provide the chain edge or that type of thing. Okay. Now, see, as we have this another alignment. Okay, and I have to provide uh, corridor to this alignment also. I hope you got my point. So for that, we don't have to create a new corridor. We have to create a one single into this single corridor. I am adding the second alignment also. Now you can see now we have as I select this, I go into the corridor properties. See, first we have only one baseline and one region. But after split this part, what happened in the single baseline into this single baseline, we have two different region. This one and this one. Okay, you can manage your frequency from here also. You can keep it like 10 feet for this region and click apply. So all the frequency for this region is 10 feet and all the frequency for this region is 50 feet. You can apply and okay. Reveal the corridor. Yes. I hope you understand these parts. Again, we go here into the corridor and we have this corridor part. This is our baseline and this one is our first and second region. Okay. Now, what we do? Now, what we do? I have to provide this corridor here also. So for that, we don't have to create any we don't have to create a new uh, corridor for that. No, don't need a new baseline. We have to manage the same thing from this corridor only. Okay, we have this one corridor. We have this one corridor. Okay, and in this corridor, we have one baseline and one region line. Okay, now what we can do, we have this another alignment and I want to provide the corridor here also. So right now, if I click here, what happen? If I click here, you can see your corridor into the object viewer. We only have this one corridor created. Okay. Now what I do, I want to add this alignment into this corridor. So for that, this is one. I have one baseline here. Okay, and then the region is come. So for that, I have to add the baseline. So after selecting this corridor, I have to add the baseline. So click onto the add baseline part. As you select, you can see the option alignment and profile and which alignment you want to create. So I have to create this one. Okay, road number 2. Okay. So they will take the profile automatically and then click OK. As now, as we select this corridor and go into the corridor surface, you can see we have the first baseline here, okay, and the second baseline, this one. I hope you are understanding this part. The baseline one, and we create the second baseline here. But in this baseline, we didn't provide any region, so no region is there. But in this baseline, we provide one region, this one. Now what we are doing, we are going to provide one region here. So for that, again we select this corridor and come here into the, we have to provide the region. So after this, selecting this, we have to provide one region here. So for that, we come here into the corridor property, we click here into the baseline, and then we right click here and we select the add region. As you select the add region, what you have to provide assembly number 1? Yes, okay. Okay, now in, we click apply and reveal the corridor and okay. Now you can see as I select this corridor, as I select this corridor and we go into the object viewer, you can see the two corridor is there. Okay, the first one and the second one. And what happened here, because we didn't maintain the elevation part here, so for that's why this problem is happening. But forget this part, you just focus on this part, that we have this one baseline, the second baseline, onto that baseline we have one region, the second region, and on that we provide the assembly. This, see, this is our assemblies, the assembly. So this is the assembly we targeted here onto this baseline. I hope this one is clear. Now, as you select this road, you can see, you can drive this. As I am selecting onto this drive part, see first what I do, I undo this and I put only this one part. So for make you better understand, as we have this one corridor, now I want to drive through this corridor. So I have to select the feature line. So from which angle you want to see, top of the curb, back of the curb, or gutter line. So I want to see the gutter line, yeah, on or top of the curb, and I click OK. So you can see this part, as our surface is not attached with the ground, so we cannot see properly this part. So right now what we are going to do, we can close it and we can create a surface. So as we have this corridor and we have this assembly, okay, as I select the corridor properties, here into this corridor properties, we have this assembly number 1. Okay. Now, here into the surface, you can see, you can create a corridor surface from here. As we have one surface, the ground surface. Now I have to create the corridor surface. So from the corridor property, you can come here into the surface. You can create a surface from here. Also, after selecting the corridor, okay, as you select the corridor, you can see you can create a surface from here, corridor surface. See, so you can create the corridor surface from here also. So you come on the same place. Now we have to select this part. The first one is the link and the second one is the top part. Okay. Now we click here into the corridor. Now you can give the name as a finishing surface, finishing surface for the corridor. Okay. And here you have to add this link. Now you can click apply and OK. Now you can see your daylight is now applying because we are selecting the corridor surface. Okay. Sometime what happen? See here into the prospector tab, you can go here into the surface. Now you can see the easy surface. If you select the easy surface, this one is the easy subject which is selected, but corridor is not selected here. Okay. Now if you go into the FS corridor and select, see this FS surface is selected. If you click into the select, see this surface is selected. It means that we have this corridor surface. And you can see the surface from here also. Okay. Now we can select this corridor. We can select this corridor and we go into the object viewer. Now you can see your corridor, a properly created corridor. See, this is your center line, the both side of lane, the curb and gutter, and then we provide the cut and fill criteria. Okay. Now, as you select your corridor, as you select your corridor, as you select your corridor, you can drive it. Okay. Now you can see you can drive through this corridor part. So for better understand that how our corridor created. Okay. It will take some time. See here the process is going on. You can see. So once it's completed, you can click onto the play button. This one. As you select the play button, your you can show your road. So this part filling cutting part, this is filling part. So this one is also cutting part. This you can see the fill part. Now you can observe your road here. You can observe. So this is our ground surface. Okay, this one is your road. Okay, so and this is attached with the surface. So this part you have to cut from this side into the profile. I will show you that you have to cut this part, and this is the maybe filling part or onto the ground surface. Now let's go here, and you can see here. So our this road, the starting road, it is under the ground surface. See till this part. So that's why in starting we only saw the ground. So we have to cut this part, and then we can see our road here from this to this, and then again we saw the ground. See our starting chain is from 0. and this one is our starting channel. Okay, as I select this and we go for the drive, and I have to select the feature line here. Okay, and this is from where you want to show. So I want to show from the ETW, edge of travel way. So travel way, at the from the edge of travel way, we can see how our road going through. Okay, now if you play the click button, so from zero station to you can see. Now you understand. This is the cutting part. Now your some part of the road is shown from the above side. Then again some ground is above your road. I will show you that here. Now you can see the first we saw some road here because we are traveling through the edge of ETW, edge of the pavement. This part you first saw the ground part and then you saw this part, and then again you saw this part, what is outside from the ground surface. Now make sure that when you create your surface, when you create your corridor surface, select your corridor. Okay, select your corridor, go into the corridor properties. Here you can see the surface. After surface you can add the different link here. If you want to add the datum part, you can add the datum part too. Here into the, you can add the datum part too. Okay, now this is for the top link. Apply. Now here into the boundary, we have to set this corridor extended outer boundary. So sometime what happen, apply, okay. Sometime what happen, so if your road is passing through this, then this surface will take over all the area. So as we extend to the boundary, it means that your surface of this corridor is limited to only between this and this. They are not covering this much of area. So this is the use of this. So again, we see the object viewer. You can now you can see your corridor. I hope you all are understanding this one part. Okay. Now let's. So this is the thing I want to explain about this corridor, that as a corridor is a very important part of the civil 3D, and the corridor, what we understand from this, that our this corridor is a combination of the first our alignment, the second our profile, and the third our assembly. So combination of these three things create the corridor. In a simple words, alignment define where the road goes from this side to this side. Profile define the vertical levels, and our assembly define the road cross section. Okay, so this is our about our corridor, and I show you that how we create our corridor by selecting the alignment, profile, and assembly. So if you selected these three things, then your Civil 3D software automatically place the assembly at the regular interval along this alignment and generate this corridor. Okay, and then we create the uh, corridor surface. Okay, now corridor surface are, they are extracted from the corridor, not from the another area. So the surface are this surface, the corridor surface, we used for the earthwork calculation. The first thing, the second thing, volume computation. The third part is for the visualization, and then to create the cross section of this road, and then to calculate the quantity takeoff. So this is the one of the most valuable output of this Civil 3D software. Now, I hope till this thing you are clear. Your whole concept is clear. You have to practice this much and much more. As we saw into the into the corridor, we see the corridor properties. We see the corridor surface, we see the head baseline, we see the split region, we see the head region, we see the frequencies, okay, and targets. We check the target as we give the target from here to here at the beginning. Okay, so this is all your corridor. Now we go for the last part, which is sub-assembly composure. This is our last part, which is sub-assembly composure. Now you can see, just give me a minute. So Rajiv ji, I hope you understand the assembly, corridor and corridor surface.
Yes, sir, understand, but I have to practice, sir.
Practice, yes. And also we have to, next day we have to, if any doubt, I will tell you, sir. But we
What,
have
what?
to practice. Next day, first we have
Ah,
to
no, no worry, no worry.
practice. Then
From
if
the
any
beginning,
confusion,
I told you that whatever you have doubt and whenever the doubt is generated, you can ask me through the WhatsApp or through the calling.
but in this
So,
section we have to do more practice and
Arey, don't worry, ask me right. Whenever you are, sit in front of the computer, in front of the software,
yeah.
you can ask me.
Okay.
Maybe if I am busy into some work, whenever I get free, I will solve your problem. You can WhatsApp me all that doubts. Okay.
Okay.
Is Rajiv ji have some doubts today from the previous session? What Rajiv ji do? They join at 2 p.m. From 2 to 15 or to 7, then they solve their all the doubt. So this is also good practice. So whenever you have doubt, you can ask me anytime. So it is not a big issue. See, this is software. Okay, it is tool. What happened in a last moment? We generate the assembly. In a new file, we see the assemblies into the metric unit. In our file, we see the assembly into the imperial unit. So this type of problem happen. So this is not a big problem. Problem is we are not understanding how to use this all that thing as per our real side, with respect to the real side. Okay, this meter and feet unit, I when I set the all that style again, so that problem will gone. This is not a big issue. So this type of problem is also there when you practice your civil 3D, because this is software. Machine will do mistake. Okay, but they are doing the less mistake. A human do the more, but without a human, machine is not there. This is also fact. So now let's go into the introduction of SAC. So what is SAC? So SAC stands for the subassembly composer. It is a separate Autodesk application used for the creating custom subassemblies. So here you can search subassembly composer because it is a separate application. Whenever standard civil 3D components cannot satisfy the project requirement, then we have to use this SAC. SAC becomes a extremely useful software. So as I am using the Civil 3D 2023, I have the Autodesk Subassembly Composer 2023. As I open it, you can see. So what is the application of this Subassembly Composer software? So this is widely used in the highways, urban roads, service roads, airport pavement, drainage structure, footpaths. If there is, if you are doing any type of civil activity, like if you are in a mining work or if you are in a airport or if you are into the railway work, if you want to create your particular assemblies, so if you want to create any particular drawing or object, you can create that drawing from here, from the subassembly composer. So large infrastructure projects often require custom assemblies. Making through this SAC is an essential tools. Now you can see the interface here. Okay, let's understand the interface. On the left side, we have the toolbox containing the points, links, and shapes. See, here into the Civil 3D, see, when I select this part, assembly part, and go into the assembly properties, you can see here link, point, and shape. Here into the sub assembly composer, point, link, and shape. So I hope you understand that with the help of these three parts, we are creating a sub assembly here. Now you can see into the link, we have the different name top, pave, datum, sub base, curve. Into the point, we have ETW, flange, all that thing. Into the shape, we have pave one and curve. So these all are the name. Okay. Now here in the right lane, when you come to here into the line right lane or a right curve and gutter, you can see here the side is right, the intersection point is there, height is there, width is there. Okay, all that thing is there. So we have to create this name, this construction part, and this codes here into the subassembly composer. So today what I do? Today I will show you the one part, and then in the homework you have to create one full one assembly. Okay. So the center area contain the this one flow chart. This is the flow chart window where we create the logic of the subassembly. Okay, the preview window help us visualize the geometry. This one is the preview window. You can manage this all window by this. Okay, you can manage this also by doing. You can manage this part also. Okay, so whatever is for the requirement, you can manage these parts. Now you can see if I am coming here into the sub-assembly flow chart, observe my arrow. As I go into the preview mode, observe my arrow. So as we are going, our arrow style is also changed. In this three part, we have the same arrow, but here in the preview, our arrow is changed. Now the properties lane panel is there. Here you can see the properties panel. So it allows us to define the parameter and values. So we can provide the parameters and values from here. Okay. At the bottom we have input parameter, this one. Okay, which control the dimension and width and slope. So here we give the dimension, width, slope, and all that things. Together, this all the parts help us to build the intelligent and reusable assemblies, sub assemblies. Now, how this all this works? So this properties, this is the properties, sub assemblies, preview. This is flow chart, preview, and the input output parameter. So understanding this workflow is very important. First, we define the input parameter. Then we create the points. Points are connected using link. See, point, link, and shape. First, we create the point, and that point are connected with the help of the links, and the link form the shape. So finally, the entire model is exported as the PKT file format. So what is the file format of this subassembly composer? .pkt. And this PKT file can then be imported into the Civil 3D. Once we create the file, we can import this file into the Civil 3D. Now, let's come here, points. So every sub-assembly start with the point. So first what we do, first we have to select the side here. Let's select the right side here. Then into the packet setting, we have to give the name. Sub-assembly 1 is the name. You can provide your any name like BATCH bed 76.1. This may be the name. Okay. Now, okay, so the dot and that part is not allowed here. So base 76 only we can put it as base 76. If you have any description, you can provide your description here. If you have some help file, you can provide that help file from the here. Help file means like in the form of the image for betterment. Okay, now into the input, you can provide this right side here. Okay, so we are creating this for the right side. Now here we are going to set all the parameter. First understand this thing. See, if if you are creating the uh, a big and difficult sub assembly, so you can use this sequence parameter. If you can provide the sequence here, and into the sequence you can do the work. In this sequence you can do the work, but right now I am not you are doing the work with help of this sequence. So we are not using this. We are working this into the flow chart only. Now what is the work of point? Now whatever I am going to import, you have to understand what I do. Every sub assembly start with the point. So we have to use the pick, drag and drop. See what I do. I pick the point from here, drag it from here to here and drop here. So this is our point number one. uh, you can see the point number one here also, P1 at the center part, and this is the properties of that point number one. So point number one is the first point, so we are not going to do any changes here. Okay, now we have to again import the second point, point number two. Okay, now we have the point number two. You can see here our point number one and two at the same place. Now what I do here into the property, you can see the point number P2. Point codes is here. So at last we see this code. Here you can see the type. So there is a different type: angle delta x, angle delta y, delta x and delta y. See, this is the x side, this is the y side, x and y. So what I do, I want this point to on the x side at some distance. So I have to choose the slope and delta x, because I want to give some slope here, and I want to put this point 2 on the x axis at some distance. So as I select this slope and delta x, so from home you have to practice all this part. You can set the x and y and see what happen here. Okay, and then last you set this slope and delta x. Now geometry property from point. So I want to introduce this point 2 from the point number 1. Slope, I want to provide the slope of minus 0.2 percentage. Okay, now delta x, which distance? So 10 distance, 10 meter I use. Now this one. Okay, now the link is created, link number 1 between the point number 1 and point number 2. Okay, now here you can see, as I do the fit to screen, you can see our point number 1, point number 2 is there, L1 link is there, and this slope is minus 2, and this distance is 10. Now if you want to put it on a distance of 3.5, you can set 3.5 here. Okay, and you can set the fit to screen. Now this distance is 3.5. Okay, so this type we can generate the first thing. Now what we are going to do, so point define that exit location into this geometry. Without point, link and shape cannot be created. So as we drag 2 points, so based on these 2 points we create the link and we create the shape. Now again I provide the third point, fourth point, then one shape is created. So therefore points are considered the foundation of every sub assembly composure model. Now let's go for the link. Now we have the point 2. Again I import one point, point number 3. I select the point and import the point here, point number 3. Now, point number 3 start from the point number 2. Okay. Now, point number 2, I want to see into the y direction. Okay, so this is x, this is minus x, this is y, this is minus y. Now, come here. What I want direction of x, sorry, y. So here again, I set angle and distance. Which one is best suitable angle? No, I don't want to give the angle. Delta x, delta y, angle and distance, delta x, delta y, delta x on surface, interpolation point, slope and delta x, slope to surface. So I am saying delta x and delta y because I don't want to give any slope here. Okay. Now our this point y point, I have to give some distance. Like I want to give distance 0.5. Okay. But what happened? This is going into the plus y. I want below side. So I give here minus 0.5. Okay. And the link 2 is generated. Okay. Now I need one point here, point number 4. So again, I provide a point number 4 here. Point number 4 is starting from the point number 3. No, but I want to start it from the point number 1. Okay. And again, I give this as minus zero point 0.5. Okay. Now the link is generated. Now I give the link. I want to add these 2 points, P3 and P4. So for that, I generate a link here. As you select the link, here you can see from what you want, link from the starting point and end point. What is your start and end point? So I am saying that my start point is P4 and my end point is P3. So you can see your this P4 to P3 one link is generated. Okay. So now what happened? If I want to change this length, this one, I want to change this slope. So I have to come here and I want to change it from here. If I say minus 1, then if I say fit to screen, then this will be tilted because again this link uh, is shifted as per this one. Okay. But what happened? I have to set the criteria here into this input output parameter because every time we cannot select this link and we do these things. So for that we, because this is only one layer, we have to create the second layer, third layer, fourth layer. So and the last thing we create the point link, and last thing we have to create the shape. As you have to give the shape here, and we have to give the shape. So we have to select this one. So this shape is selected. Now we have the this one have a shape also. Now in Civil 3D, you see the name, the top pave, datum pave, sub base pave, the shape is here, pave one curb, and the point is here, and link is here. So all this name, so all this name, we have to give all that name here through the code. Like if we are into the P1, so here, what is this? The crown. So we have to give the crown part. So as you set the crown and you set fit the screen, so the point code of a crown is there. Okay. So first we have to select all the criteria. Then we are coming here into this part. I will show you all that part. Then how you can import all that things, point code and all that. So now what I have to do. So here this is the codes part. Okay. So into this code, I will show you all the things. Now first, what you want to set here into the input output parameters. See, into this package setting, first of all you set the base name, then here input and output, we have to create a one parameter. parameter. We have to give the parameter name as a lane width. Make sure that here into the name you don't give the any spacing. Lane width. Okay. Here in the inside you have to select the double. Okay. You have lots of option. You have to select the double part. Into input you have you keep it as input. Now the default value we can set it later. In a display name you can this name you can show into the civil 3D part. Okay, so here you can provide the parameter. Now create the second parameter here. uh, Now we need a lane thickness also. Lane thickness here also I have to provide the double input. Then the name also we can provide as a lane thickness. So first of all we need the width, then we need the thickness, now we need the slope. So now we provide the pro slope. Pros here you don't have to give any space. Now slope is in a gradient, and then here you can give the text display name cross slope. Okay, then so this three parameter you have to set. Now you can go here into the target parameter. Here into the target parameter you can see first lane offset. We have to provide the lane offset. So first we are give the name lane offset. Then our target is here you can set the offset. Now we have the preview display name. So the display name you can set as a lane offset. So as I'm going to write down here, you can see the some changes here. As we go inside, you can see the different changes. Now I can create the second parameter, um elevation. Okay, I have to give the elevation. Here into the elevation, we have to set the elevation. Here you can give the display name as a elevation itself. Now we have the third parameter we have to set is a elevation target or the super elevation. But we can add the super elevation here into the input tab. So in target you can set these two, and if you want you can create the surface also. Here into the you can set the surface. Okay, these three things you can set here. Here in input again you give the new parameter. You can say it as a super elevation. Barabar. Here you can take the super elevation axis of rotation. As you select this part, here you have to see your support AOR. Uh, Make sure that this will be unsupported, because if you see the supported it means that you are stuck at the one option. Unsupported means the rest of the option you can use in the civil 3D. Okay, here into the name you can provide any name. Okay, and at last we provide the material this one, the in between what material we are going to use. So we can give the name as a material. Okay, here you can set the material. Because we are providing the name, we have to choose it as a string input. Here we can give the name of the material, and here also display name we can say material. Okay, now our all codes are most probably set. Now let's do one thing. Let's give our lane width is a 3.5 meter. we provide our lane thickness is 2%. Okay, and sorry, lane thickness is 0.5, and our cross slope is a 2%. Okay, and let's give the name as a like concrete. Okay, we provide this all the we set this all the criteria. If here you can come in a land offset, if you want to give, you can provide the offset of 5. Elevation, you can set the elevation at any point, like 1 or 2 or any point. But right now we are not giving anything here. So this is what all I manage all that things here into the properties. Now what I have to do, I just provide this input, this name here in this portion. Like you can see here P1 and P2. Okay, we have the slope. So for slope we provide the 2%. See this one. But every time I have to search this point, and then I have to provide the slope name. Instead of this, what I do, I provide this name, the 2% slope, this cross slope name. I copy this name and I provide this name here, control V. See, now you can see we have the 2% of slope. If I provide the slope of 5%, automatically this slope change. I don't have to come here and change the slope from here. From this step you can manage. And what is this step? This one. I hope you understand this one. As we open this subassembly property and we go into the parameter, so this all parameter we set here into the subassembly composer, this one. Okay, so what you do here in civil ready, you just provide the different width or different slope here, and directly the slope is changing here. So the same way we provide here, we give the slope of 2 meter. So 2 meter slope automatically provide here. I hope you understand this part. I hope you are not getting bored. You are getting interest in this session.
No, sir,
Rajiv ji?
no, sir. Sir,
Yes.
uh, I think we should, sir, finish for today, sir.
Yeah.
So long.
Too much time taken.
So it is okay. Give me only 5 minutes. I will complete the session. Don't worry.
Okay.
Because I start this, so I have to end this. So only 5 minutes. I'm taking so more. I hope you understand this one. Like see here, this is the width part. Okay, and we set the width here 3.5. Now what I have to do? I have to take this name, the same name. I have to paste here. Now, if I want to change the width, now 3.5 width, I have to change the width 5 and say, see, the width of 5 meter is there. Now we don't have to put anything from here. We have to manage all the thing from here. Now make sure that if your elevation is on, then your super elevation is not working. Okay, so if you want to work the super elevation, then you have to set the elevation as a off. Okay, if your elevation and is off, then it will be work properly, your super elevation work properly. Or if you provide this elevation part, then no need to provide the super elevation. Then if you change the super elevation, nothing is going to be changed here. Okay, next and last thing is there, the codes. If you said, see, now this target, how to provide this target? Like you can see the point number P2, this one. Okay, here in, if you provide any point from the link, you have to select the link here. You have to click apply AOR. Apply AOR means this super elevation is there. but you provide apply AOR in whatever the input you provide here. So for that, for seeing that input, you have to click this elevation off. Okay. So at every stage, wherever you go, you have to apply the AOR. Okay, you have to provide this delta x and delta y based on this name. Okay. Now the codes. So here in the shape, you can see there is a shape code is here. So for that, what you have to do? For shape code, we provide the material. Okay, so here we have to provide the name material, but we have to provide the name into the double inverted comma material. Okay, so the next, if we are into the P1, okay, so in this at this point, so we have the code as a crown. So we have to provide the this point code as a crown part, CROWN crown. But we have to put it as a double inverted comma. Okay, you have to select all the things on. See, now I provide the crown part, I provide the shape part here as a material, but nothing is shown here. So for that we have to provide this code on. So as you see, the material, the crown, see this part. So whatever the name we provide, you can see the name here, and into the Civil 3D, you can see the name, the crown, the ETW, sub base, pave, like top pave. I want to give the name top pave. So here is a L1. Into the L1, I have to give the P3 point. I have to give the name as a top double inverted comma. Then we have to give this, and then we have to give pave. If we have two name, then we give the name at this type. So as we say point 3 is a bottom pave. Point 3 is a bottom pave, not top pave. So you set as a bottom. So as you set the bottom, now you see here the name bottom and pave. So at this type, so you have to do this work when you create the point. You have to manage this criteria and go for the next point, next point, next point. So this type, and then what you have to do, you have to save this file, save as at whatever the folder you want to save, like a subassembly number one. I save this file at on the desktop. Okay, now we have this .pkt file. Okay, so this is the type our file is generated. Now what happened? Now you can see here into the subassembly composer, I created one subassembly composer file here into the download. See, subassembly part 1. I can open the subassembly. You can see this type of subassembly I create here. Okay. Now, so you can provide the subassembly like this. You can set all the thing, and you can see I provide my thickness. So where it is belong to the thickness point P3. So I have to provide the thickness, and a thickness I have to manage thickness from here. Okay. Now if I am going to give the point 20, then see the 20 thickness is there. Now this is the how we can start work here is a civil 3D sub assembly composer. Now the last and final thing I want to show you how we can take that sub assembly sorry, here in this project. So as we have this palette bar, okay. Now here on this tab, lane, shoulder, median, you have to right click here, and you have to set the new palette and give the name of that new palette as a batch 76.1. Now this is the new palette batch 76.1. Now I have to add the assembly here. So what I have to do, I import the subassembly source file. Yes, I have the file. So I have this one file here. I provide that file. See, I have the one layer is here. Now, and see the all that things is provided here into the layer. Whatever the thing I create, side, thickness, grade, super elevation. So see, as we support unsupported, so you can set it here. The side you can change it from left to right. Okay. Now I will show you what we create and how it work here. Create the sub assembly. Okay, sub assembly number we give the 5. Okay, I will put the sub assembly here. Now I provide this part here at the right side. Now you can see whatever the sub assembly we create, the sub assemblies work properly here. We can mirror this sub assembly here. Now on this road, we have the corridor. We have the corridor. We select the corridor. We have to select the corridor first, and then we go into the corridor property. Now here into the parameter baseline, we have assembly number 1. So now we have the assembly number 5 that we recently create with the help of the subassembly composer, and we apply rebuild the corridor and OK. Now see, your new subassembly is imported here. Now you can see your this is your first lane and different layer. See, sub base layer. This is the your first top layer. This is your second layer. This is your third and last layer, sub base. So different 3 layer is there. Here in your assembly also we created these layers, and the same way you can drive and check this from the crown tab. You can play it. Now you can see your road. See, now you can see your road with different layer. So the new assembly we created, we can see here. Now here, I can show you this part. So what is this? This is the eyesight. You can set this eyesight. Means if you set this, so you can set from from where you want to see. So your eyesight and the screen distance. So you can set this eyesight. So this is for up and down. This is for side and left and right. Now this one. This one is you have to set this if you want to see it from the very near and you want to see what is the changes is there. Now you can see the mode also. You can see the mode. If you want to see the realistic view, you can see the realistic view. If you want to see different view, you can see. You can manage the design speed also. If you want to see on the speed of 50, so you can play and you can see the speed of 50. So this is the cutting part and this one is the filling part. Okay, I hope you understand this all that thing. So for today, this is enough, I think. So you can learn 2 lecture in only one series. So I understand, but I hope we have the till the next Saturday we have more 5 or 4 days. So I hope you all are practicing these things because this is very important.
Yeah.
Once you prepare the corridor and these things, then any type of corridor is there, so you can understand what is the region point, what is the base point, how you target the thing, how you give the frequency. Okay, so the same file I will share you, I share with you, so you can practice by watching the file. Okay, I hope you understand all the things and I explain you all the things in a very well manner. So today we what we see That assembly defines the road cross section. Sub-assemblies are building blocks of assemblies. SAC enables customizations. PKT file form is transfer the custom component into the civil 3D, and corridor transfer from 2D design into the complete 3D road model. So finally, this is the ultimate objective of the entire workflow. Okay. So what started as a simple alignment has now become a realistic highway model. So this model contains lanes, shoulder, medians, slope, and drainage element. Such models are used for the design approval, visualization, earthwork analysis, quantity estimation, and construction planning as well. So this is exactly how modern highway projects are developed in a professional consultancy environment. So thank you everyone for your attention. I hope this session help you understand how Civil 3D and Subassembly Composer work together to create the complete road corridor models. In our next session, we will learn the sample lines, cross section, and earthwork quantity calculations. So once again, thank you all and all the best for your Civil 3D learning journey. And with this, we conclude our session. I hope you enjoy the session. And with this, we end our session. Thank you, everyone. Now you can leave the session. Thank you. Thank you
Thank
so much.
thank you. Thank you.